So far we have seen we can use a pair of transistors which are connected in a cross-coupled manner to realize a negative resistance. Now we will try to understand if a single transistor can also be used to realize a negative resistance. Realizing negative resistance using a single transistor. So if we take a NMOS which is biased in saturation and we connect the gate and source terminals through a capacitor, also the drain and source with a capacitor. So this is the gate, drain, source, and then try to observe the impedance between the gate and drain. You will find that this impedance Zin can have a negative real part which can be later on utilized for designing oscillators. So to find what is this looking at impedance, we can connect a test source and find the test current. So here the MOSFET is biased in saturation, the transconductance of Gm. Let's say these two capacitors are C1 and C2. And we connect a test source Vs, trying to find what is this current Is. So we can just go in this loop and we can use KVL. You can write the voltage drop going through the loop. So we can see that at this node, so this current which is coming is Is, and the drain current is going to be equal to Gm times VGS. Okay. So now we can see that the current going towards C1 is equal to Is minus Gm times VGS. Now we can see the voltage drop across C1 is 1 by SC1 into Is minus Gm VGS, and this drop is minus VGS, which is also equal to finally this current which is Is, so Is into 1 by SC2. So it's going to be minus VGS. This should be equal to Vs, and we can already see that this minus VGS is equal to Is into 1 by SC2. So VGS is equal to minus Is by SC2. Together we can see that 1 by SC1 Is minus Gm times minus Is by SC2 etc. plus Is by SC2 is equal to Vs. Implies Vs by Is is going to be equal to 1 by SC1 plus 1 by SC2 plus Gm by S square C1 C2. So if we are interested in finding the impedance at some frequency omega, we can replace S with j omega. At omega, this impedance is going to be equal to by j omega C1 plus 1 by j omega C2 plus Gm by j omega square C1 C2 is equal to 1 by j omega C1 C2 by C1 plus C2. And here we can see we will get a real term because its j square will become -1. So we can write it as Gm by omega square C1 C2 with a negative sign. We can see that this looking at impedance in this simple circuit with a single transistor and these two capacitors is looking like as if there is a series combination of C1 C2 coming in series with a negative resistance. Equivalent circuit is going to be C1 C2 Gm. This is equivalent to having a capacitor which is series combination of C1 C2 and a negative resistance of value minus Gm by omega square C1 C2. Now we have got this negative resistance. So we should be able to use the same technique as we used in the case of cross-coupled LC oscillator. And we can use this negative resistance to now compensate loss in a LC resonator so as to result in a sustained oscillation.